All right, this is chapter 2.4, Algebraic Reasoning. And the essential question is, how can algebraic properties help you solve an equation? What you will learn in this chapter, that's the plan anyway, is to use algebraic properties of equality to justify the steps in solving an equation. Okay, so we're going to be solving equations and then justifying each step. So this is kind of setting up for what is called a two-part proof, where you have a statement and a reason, and we'll get into that. So use the distributive property to justify the steps in solving an equation, and use properties of equality involving segment lengths and angle measures. Okay, using algebraic properties of equality. When you solve an equation, you use properties of real numbers. Segment lengths and angle measures are real numbers. So you can also use these properties to write logical arguments about geometric figures. So the core concept from this chapter is algebraic properties of equality. So first we're going to let A, B, and C be real numbers. Okay, so that's just putting them in the real number set. They're not imaginary. Addition property of equality says that if A equals B, so in other words, if A was 2, then B would be 2. So if A equals B, then A plus some number C equals B plus some number C. So I'm going to give you quick examples of these as we do it. So for these examples, I'm going to say let A equal 4. Let B equal 4 for this one, and let C equal 3. I don't like using zeros or ones when I explain these because 0 is the multiplicative zero property, and 0 is the identity for addition. 1 is a multiplicative identity for, or I'm sorry, 1 is a multiplicative identity, and you multiply by, so if you multiply by 1, nothing changes. So I don't like using zeros or ones. So this here says if A equals B, so A equals B, 4 equals 4, then A plus C equals B plus C. Since A and B are equal, that means if you add a number to both of them, they're still going to, the sum is still going to be equal. Obviously, 7 equals 7. I forgot to put the 3 here for C. Okay, so C is 3, A is 4, B is 4. Using these three values, then 4 plus 3 equals 4 plus 3 is obvious because A equals B. All right, so then it says if A equals B, then A minus C equals B minus C. So A is 4 minus C, which is 3, equals B, which is also 4 minus 3. So 4 minus 3 is 1, and 4 minus 3 is 1. 1 equals 1. Okay, and now let me erase this and start in a new location. How about right over here? If A equals B, then A times C equals B times C, where C does not equal 0. So 12 equals 12 is true. The reason it says C does not equal 0 is because A and B would then not have to be equal. If C is 0, C times 0 is 0, B times 0 is, I'm sorry, if C is 0, B times 0 is 0, and A times 0 is 0. So if C equals 0, A and B would not have to be equal is what that means. Okay. All right, next scenario. Let me make my eraser bigger. Erase more at a time. If A equals B, it does, 4 equals 4, then A over C equals B over C. Okay, since C is equal, if A equals B, if the denominator is equal, in other words, and if the numerator is equal, then the fraction is equal to itself. The reason here it says C cannot equal 0, well, if we made C 0, I'll just do it on this one side, 4 divided by 0. You cannot divide by 0, it's an undefined. You're gonna, if you put it in a graphing calculator, it would say error on UNDEF or UNDF, something like that. Error undefined. Okay, So you cannot divide by 0. So that's why they're saying C cannot equal 0. And then the substitution property of equality says if A equals B, 4 equals 4, then A can be substituted for B or B for A in any equation or expression. Okay, so that makes sense. If they're equal, you can substitute them. So those are the core concepts of the properties: addition property of equality, subtraction property of equality, multiplication property, division property, and substitution. So let's look at some examples involving those. Okay, so example 1, justifying steps. It says solve the equation 3x plus 2 equals 23 minus 4x. Justify each step. Okay, so I'm going to stop right there and I'm going to change and I'm going to say something about what we're doing here. So let me, it's order of operations. Okay, so a lot of teachers use the acronym PEMDAS, parentheses, exponent, multiply, divide, add, subtract. I prefer using the letter G because it represents grouping. It doesn't have to be parentheses. It could be a numerator. It could be under a radical. It could be the radicand. It could be a number of things that are grouped together, and you always do your grouping first. So that's why G comes first. Then you focus on exponents. Then you focus on multiplication and division. And how about I change these two colors to green and these two colors to, let's say, I don't know, red, it doesn't matter. And the reason I'm color coding those is because when you get down to just those, you work left to right. Okay, and then over here, I have it written backwards, and it is SAD Meg in this case, solving equations. This is when you're crossing the equal sign. You have to go across the equal sign. You're going to use the inverse of the operation that's being done to the expression. So what does this all mean? Well, the first thing I focus on whenever solving an equation is, can I simplify anything on one side? So I have 3x plus 2. 3x and 2 are not like terms. I can't combine them. There's nothing I can do with these. There's no distributive property, nothing. If I move over to here, I have 23 minus 4x. I have a constant minus a coefficient times a variable. It is also called a binomial. There's no simplifying done here, so I cannot do any order of operations here. Okay, so then once we realize we cannot simplify anything on either side of the equal sign, then we switch to solving equations using the reverse order. So the first thing I want to do is focus on subtraction. And I see 3x plus 2 equals 23 minus 4x. I like to focus on the variables first, and I like to move the smaller of the two so that I don't end up with a negative. So the first thing I'm going to do in solving this problem is focus on the variables. So I have a minus 4x here. I want to move it over to the other side of the equal sign. So I'm doing the inverse of subtraction, which is addition. So I'm going to add 4x. I'm going to add 4x. Okay, so 4x plus 3x is 7x plus 2 equals 23, because minus 4x plus 4x is 0, and 23 plus 0 is 23. So the first thing you're going to do, actually what I should have started with, is rewrite the problem. So let me do that. Let me start this again, but that's okay. Just follow along. First thing that you should always do is rewrite the problem. So write 3x plus 2 equals 23 minus 4x. And the reason over here, so this is your statement. Okay. And over here is your reason. All right. So we have a statement. We write it. And the reason, well, that was given. They gave us this problem to solve. That is what is called a given. So then when I add 4x to both sides, like I've already shown you, then I get 7x plus 2 equals 23. The reason for that is the addition property of equality. Okay, what you do to one side, you do to the other. So that is the addition property of equality. Okay. And let me see if I can clean this up a little bit. Okay, when I'm attached to a smartboard, I can change the handwritten to text, but I can't do it without, so that's what I was checking. So let's just continue. So then what do? Well, we still have this equal sign and we're trying to isolate the variable we have at now there's nothing more I can simplify over here. So I look over here and there's addition. So that we're at this step now. So the inverse of addition is subtraction. So we're going to do the inverse operation to move it across the equal sign. So I subtract 2 from both sides and I get 7x equals 21. And that is the subtraction property of equality. Okay, you might be wondering, where am I getting all this from? Well, let's go back here. Subtraction property of equality. We just did the addition property of equality. If A equals B, then A plus C equals B plus C. So that's what I'm using here. I'm using the core concepts, the properties of equality. So now I have 7x equals 21. I want to get x by itself. Since x is being multiplied by 7, so we're on this step right here. The inverse of multiplication is division. So I'm going to divide to move the 7 across the equal sign. Hopefully that makes sense to you when I explain it this way. And when we divide both sides by 7, we get x equals 21 divided by 7, which is 3. And that is the division property of equality. The division property of equality. So the solution is x equals 3, and you should always check it. And then I can just do it in my head up here. 3 times 3 is 9, plus 2 is 11. 23 minus 4 times 3, which is 12. 23 minus 12 is also 11. 11 equals 11. My answer makes sense. Okay, so now we're going to look at the distributive property. The core concept of the distributive property is that A, B, and C be real numbers. The sum A times the quantity B plus C equals AB plus AC. So let's talk about that for a second. So let A equal 2. Let B equal 3. Let C equal 4. So if we have the A parentheses B plus C, then that equals, and what they're doing is they're distributing A times B and getting AB, keeping the sign here since A is positive out front, and then A times C is simply AC. So we're going to do that here. 2 times 3, and I'm not going to write the answer, I'm just going to show it. 2 times 3 plus, and then I distribute the 2 to the 4. 2 times 4 is 2 times 4. So this is going 2 times the quantity. 3 plus 4 is the same as 2 times 3 plus 2 times 4. Now I can take that one step further and say that is 6, and this is 8, and 6 plus 8 is 14. Now, I'm just proving this to you because if we did order of operations and we know the both values in this parentheses, there's our grouping, we do that first. So if I used the order of operations to answer this question, I would simplify the parentheses first, getting 7, and 2 times 7 is 14, and we get the same answer. Okay, so now let's look at the difference. Well, we have A, which is 2, and we have B, which is 3, and we have C, which is 4. That should equal 2, which is my A, times my B, which is 3, minus A times C. So what we're doing here is we're distributing 2 times 3 right here. The sign comes over here because 2 is positive, and a positive times a negative is a negative. And then we distribute the 2 times 4, and we just write that over here. So it's just simply this times this minus this times this. 2 times 3 is 6, minus 2 times 4, which is 8, giving me -2 if I were to simplify that. Now, again, if I use the order of operations here, not the distributive property, then I would get 2 times the quantity 3 minus 4 first. 3 minus 4 is -1, and 2 times -1 is -2. And as you can see, we do get the same answer. The reason we have the distributive property, though, is because sometimes we don't know the value of a variable at a given moment in an equation, and using the distributive property is part of solving for unknowns. And we can't do in the parentheses first if we have, so for instance, a equals b minus 3. I can't subtract 3 from b if I don't know what b is, so we have to distribute. And we'll take a look at that now in an example. Okay, so here's example 2 using the distributive property. So step 1, always rewrite the problem. -5 times 7w plus 8 equals 30. So this is our equation. We are going to eventually just call this a statement when we do this. And I'm not going to write the reason, like the book shows what is actually happening, the explanation. I'm just going to explain it verbally. And we're going to just do the reason over on this side. Okay, so I look at this equation. 30 is all by itself on the right, and I have a distributive property scenario on the left. So I'm going to use order of operations, which is grouping first. I can't add 7w to 8, so that grouping is done. Okay, so let me bring that in, and as I'm saying it, I'll cross it off. Okay, so here we go. So I'm going to have this off to the side here. It's not necessary every time, but I just want you to get a feel for this. So we are simplifying the expression. We're simplifying the left side. We're not crossing the equal sign yet, so we're not doing these orders, which require solving the equation using inverses. So looking at simplifying, start with G, grouping. 7w plus 8 cannot be done. They're not like terms, so there is no grouping I can do. There are no exponents, so then I move on to M, multiplication. Well, that is the distributive property. So I'm going to write this: -5 times 7w plus, I'm going to distribute, and it's -5 times 8 equals 30. Okay, so that's the distributive property. So it says using the distributive property. I could have done something different here, but I'm not going to, because we are doing the distributive property. It said to do the distributive property. So when I multiply this throughout using the distributive property, I'm going to get negative times a positive is negative. 5 times 7 is 35w. A negative, and then it's going to be plus, but then it's going to be a negative, so that's going to be minus. So now it's -5 times 8, which is -40. Watch your sign there. -5 times 8 is -40, plus a negative is just simply minus, equals 30. Okay, so the reason there is, well, that's the distributive property. So up here, the reason was given. You write the equation and you write given, and this is the distributive property. Okay, and now we cannot simplify the left side anymore. 35w and 40 cannot be combined. It is an expression that cannot be simplified. We now are done with this side entirely, and now we're over here. Do we have any subtraction? Yes, we do. It is right there. So we're going to do the inverse operation of subtraction, which is addition. What you do to one side, you must do to the other to keep the equation equal or level. -35w stays, and -40 plus 40 is 0. -35w plus 0 is just -35w, and 30 plus 40 is 70. So that is the addition property of equality. Okay, and then now we have, so we've done addition. We don't have any division, but we do have multiplication. -35 times w is multiplication. The inverse of multiplication is division. The inverse of subtraction was addition, and that's what we did. So we're going to divide by negative 35. So that would be my explanation. Divide both sides by negative 35. Okay, and these cancel. Actually, I don't need that line. That just confuses things. Divide by negative 35. Divide by negative 35. A negative divided by a negative is positive, and we're left with W. 70 divided by a negative 35, positive divided by a negative is negative. 70 divided by 35 is 2. That is the division property of equality. Okay, and that is our answer to the problem. W equals negative 2. Now I'm going to check it. So I will put negative 2 in right here. 7 times negative 2 is negative 14. Negative 14 plus 8 is negative 6. Negative 6 times a negative 5 is positive 30. It checks. There's the answer to the question with reasons given. Okay, now we're going to jump to a real world scenario. So you're probably asking yourself up to this point, where are we ever going to use this? Well, this is a really good example of where you could use it. So here's example 3. You get a raise at your part-time job. To write your raise as a percent, use the formula P times the quantity R plus 1 equals N. P is previous wage. R is the percent increase as a decimal. And N is your new wage. So you take your initial previous wage. So if you multiply your previous wage times 1, that's your previous wage. That's 100% of your wage. Add an increase to it, and now you're making, say, if you get a 10% pay raise, you're making 110% of what you used to make. You're not making 10% of what you used to make. You're making 110% of what you used to make. You're making 10% more than 100% of what you made in the past. And that's what that 1 means. It's 100% of what you made plus some amount extra. Okay, so hopefully that makes sense to you. It just saves a step at the end rather than just finding P times R and then adding it to P at the end. Okay, because that's a distributive property. So that's going to come into play here. So it says, what is your raise written as a percent when your hourly wage increases from $7.25 to $7.54 per hour? Okay, so solve the formula for R is the first thing we want to do. That's the first thing it said to do. So the first thing you're going to do is write the expression or equation, in this case, P times R plus 1 equals N. Reason given. So I want to get R by itself. So how about, let's just highlight it rather than color coding it all. Highlight it. And so I want to get that by itself. Well, how do I get that by itself? You move everything away from it. So this is an example for the distributive property. So that's the first thing we're going to do. We're going to distribute. So we're going to get P times R plus P times 1 equals N. Okay. So that is the distributive property. Okay, so what did you do and what's the reason? So this simplifies to PR times P, because P times 1 is simply P. Let me get rid of that 1. I just wanted to show that at first. So we have PR plus P equals N. So we're trying to get R by itself. So you ask yourself, what do we do now? Now we're moving across the equal sign and we do order of operations. There's no grouping. There's no, SAD Meg, there's no subtraction, there's addition. The inverse of addition is subtraction, so I'm going to subtract P from both sides. This is going to give me PR equals N minus P. And that is subtraction property of equality. Okay, subtraction property of equality. And then just to get r by itself, now this is multiplication. The inverse of multiplication is division. So we divide by what we're trying to move, and that is p. So p divided by p cancels, and I'm left with r equals n minus p divided by p. And that is division property of equality. Okay, so this is the first part of the problem. It said solve the formula for r. So here it is. And then it says, what is your raise written as a percent when your hourly wage increases from 725 to 754. So what we're going to do is, well, what are these values? Previous wage is P. That's here. So I'm just going to write these over here. P equals 725. And your new wage is N. So N equals $7.54. So we were given P, we were given N, we want to find R. So step one, write the formula. R equals N minus P divided by P. We substitute in what we know. We're trying to find R, and that's why we solved this for R in the first place. Everything we're plugging in is going to be on the other side, and the answer, when we simplify it, will be the answer to this question. So N is 754 minus P, which is 725, divided by P, which is 7.25. So R equals, so we simplify here. Order of operations says parentheses or grouping. So there's a perfect example of this. The numerators group together. We do that first. I can't subtract 5 from 4, so I have to borrow from this tens. So that's a 4 now, and this is 14. 14 minus 5 is 9, and 4 minus 2 is 2, and 7 minus 7 is 0. So that's 29 cents over 7.25. So it says, what is your raise written as a percent? So now that I have 729 over 725, I can go to my calculator. And I take 0.29 divided by 7.25, and that equals 0. What was it? 04. 0.04. Write your wage as a percent, raise as a percent. Well, percent means to move the decimal 2 places to the right and change it to percent. So that is going to equal 4%. And that's the answer to this question. You got a 4% pay raise. All right, using other properties of equality. Yes, there are more. The following properties of equality are true for all real numbers. Segment lengths and angle measures are real numbers, so these properties of equality are true for all segment lengths and angle measures. So what they're basically saying here is we've been doing algebra again, but this is going to transfer over into geometry. So core concept, reflexive, symmetric, and transitive properties of equality. So the reflexive property states that for all real numbers, A equals A equals itself. For segment lengths, the length of AB equals the length of AB. And for angle measures, the measure of angle A equals the measure of angle A. The reflexive property simply states that something is equal to itself. And the main reason for this is if you have a triangle and you're working with an angle in it and it's shared by another triangle. For example, if I had this little triangle right here and I called this angle A, and then if I had a bigger triangle that came out further like so and was this big red triangle, Clifford the big red triangle, then this angle A here is equal to the angle A in both triangles. So the measure of angle A equals the measure of angle A. when I go to move the red triangle. Okay, so if this was angle A, this is also angle A, and they're equal in both triangles. And that's why the reflexive property is so important. Okay, symmetric property. If A equals B, then you can say it in the other direction. Then B equals A. If segment AB equals segment CD, then we can say segment CD equals segment AB. Okay, you might think these are really obvious, but then when you go to do a proof, you forget the obvious and you struggle with the proof. So you have to be really aware of where these can be used. If the measure of angle A equals the measure of angle B, then we can say it in the reverse. Then the measure of angle B has to equal the measure of angle A. And the transitive property says if A equals B and B equals C, then A equals C. So I'm going to give you an example on that. So if A is 1 plus 3, and that equals 4, that's B. So this is A, this is B, and B equals C. Okay, so if A, 1 plus 3 equals 4, that's true, A equals B. And B, which is 4, equals 2 plus 2, which is C, well, that's true. Then A equals C. And 1 plus 3 does equal 2 plus 2. So what happens is the middle term, or the B in the middle, cancels, and you can simply say A equals C. That is the transitive property. All right, so with line segments, you can say if segment AB equals the length of segment CD, and the set length of CD equals the length of EF, then the length of AB equals the length of EF. So again, the repeated middle cancels, and we get AB equals EF. If the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then we can cut out the middleman and say the measure of angle A equals the measure of angle C. Because if A is 30 degrees and B is 30 degrees and B is 30 degrees and it's equal to C, which is also 30 degrees, then A 30 degrees equals C 30 degrees. Okay, example for our first two-part proof. Using properties of equality with angle measures. You reflect the beam of a spotlight off a mirror lying on a flat stage as shown, and then it reflects back up. Determine whether the measure of angle DBA, and I'll mark it here with red. Here's DBA, this whole thing here. Determine if those two angles equal the measure of angle EBC, and EBC is these two angles. So are these two angles equal to these two angles? That is the question. So the first thing we're going to do is start with what our givens are. And what we want to say is, notice is that this mark right here and this mark right here determines congruency. So I don't know if I shouldn't use one mark here then, because that would mean that those two are congruent to these little ones, and that's obviously not true. What we're trying to prove is these two are congruent. So I'll use two congruent markers like so, but we don't know for sure yet. So I'll put a question mark there until we're done. All right, so angle 1 is congruent to angle 3. We were given that. So I'm going to say the measure of angle 1 equals the measure of angle 3. And the reason is given. Okay, it was marked in the diagram. Angle 1 is congruent to angle 3. Congruent means the angle measures are equal. Okay, now what we want to do is use an add these two angles up and name things. So I'm going to say angle CBE or DBA. We can start either way. So let's start with, well, they're talking about DBA first here. So what about DBA? The measure of angle, oops. So I'm just copying now what this says right here. So we're trying to prove the measure of DBA equals the measure of EBC. So we're going to start with this side and try to work towards saying that it's equal to that one. So I'm first going to say that the measure of angle DBA equals, and D is here, B is here, and A is here. So it equals DBA DE, which is angle 2, plus EBA, which is angle 3. Okay, so the measure of angle DBA equals DBE, which is angle 2, and EBA, which is angle 3. And the reason for that is angle addition postulate. Okay, so the measure of DBA equals the measure of angle 2 plus the measure of angle 3. All right, so then what can we say? Well, angle 3 is equal to angle 1. So wherever we see an angle 3, we can replace it with the measure of angle 1. So I'm now going to say the measure of angle DBA equals the measure of angle 2 plus the measure of angle 1. So 2 plus 1 is over here. Well, how can we say that? Well, angle 1 equals angle 3, and here's an angle 3, so the measure of angle 1 can replace the measure of angle 3. So that is the substitution property of equality. Okay. I'll just shorten it with substitution property. So that now we are saying the measure of DBA equals the measure of angle 2 plus the measure of angle 1. Okay. And then we can say, well, what do you know about the measure of angle 1 plus the measure of angle 2? Well, the measure of angle 1 plus the measure of angle 2 from the diagram, 1 plus 2 is this green thing here. Now that's the angle EBC. So they equal the measure of angle EBC. And the reason for that is the angle addition postulate again. So this is also angle addition postulate. Okay, so the angle 1 plus angle 2 equals all of this green double arc here. And now look what we have. If the measure of DBA equals the measure of angle 2 plus the measure of angle 1, and the measure of angle 1 plus the measure of angle 2 equals the measure of angle EBC, here's I'm going to highlight. This means the same as this. So we have an A equals B, B equals a different thing, which is C, therefore A equals C. So I'm going to now write the measure of angle DBA equals the measure of angle EBC. And that is the transitive property. The transitive property now shows this being proven. Okay, so that is proving those two angles are congruent. Okay, example 5, modeling with mathematics. This actually kind of sounds like a riddle or a joke. A park, a shoe store, and a pizza shop and a movie theater are located in order on a city street. So a park, a shoe store, a pizza shop, and a movie theater are located in order on a city street. So I can change this to, okay, so you want to do this as a linear because it's on the same street and the distance between the park and the shoe store. So we can do this. We can put a dot and call this the park. And then we go like this and we say shoe store. So it's always a good idea to create a diagram, draw a diagram. So there's the park, there's the shoe store. It's a certain distance on a city street. The distance between the park and the shoe store is the same as the distance between the pizza shop and the movie theater. So then we go like this, and then we say, okay, well, maybe right here's the pizza shop. And then finally the theater. Theater, not theatre. Anyway, the distance between the park and the shoe store is the same as the distance between the pizza shop and the movie theater. So I put these little markers here. Let me do it in red. So that means that this piece is congruent to this piece. Show that the distance between the park and the pizza shop, which is this distance, actually, let me do it with a highlighter. So the distance between, show that the distance between the park and the pizza shop. So I'll use blue. The distance between the park and the pizza shop is the same as the distance between the shoe store and the movie theater. So I want to show that these two distances are the same. So here we go. Okay, so we were given two things, and you always start with your givens. So let me get my pen, and it says the distance between the park and the shoe store. So let's call that PS. The length of PS is same as the distance between the pizza shop and the movie theater. So pizza, pizza Z, because we can't use P again. Park, pizza starts with P. So park to shoe store is the same as pizza to theater. So let's call that ZT. So PS, the length of PS equals ZT. Okay, so this is going to be Z, this is T, and this will be S, and this is P. So PS equals ZT. Reason given. We were told that. Okay, so the next thing we want to do is say, well, what do we know about this distance here? What are we trying to show? Show that the distance between the park and the pizza shop, park and pizza shop is Z. So we want to say something about PZ. What does PZ equal? Well, PZ equals PS plus SZ. And that is a segment addition postulate. So when you do proofs, the hardest part is getting started. A lot of times students struggle with, where do I begin? Well, you begin with your givens. And so you begin with drawing a diagram as well. And then you start with your givens and you say, well, they told us that PS equals ZT, that's a given. And then you read what you're trying to prove, and you start with the first thing in the proof, like it says, show the distance between the park and the pizza shop. Park and pizza shop is PZ. Show something about PZ. And so what does PZ equal? Well, it equals PS plus SC. So the next thing we want to do is let's see. Theater. Then what do we know about the theater? Well, we want to take what about this length here? Because we're trying to prove these two. So how long is the shoe store, the distance from the shoe store to the theater? So you'd say ST equals, and that is going to be SZ plus ZT, and that is also the segment addition postulate. Okay, and then let's see, then we have to think about this a second. We have PS plus SZ. Okay, so PS plus SZ, which is right here. Let me highlight that. PS plus SZ, which is PZ. Oops. PS plus SZ equals ZT plus SZ. Okay, so what am I saying here? PS plus SZ. PS is this piece plus SZ is this center piece equals ZT plus SZ. Since these two segments were congruent, then PS plus SZ equals ZT plus SZ, and that's the addition property of equality. All right, so now what are we trying to prove? We're trying to prove that PZ equals the distance from the shoe store to the theater, ST. So what we're going to do now is say, well, PZ equals ST. So PZ equals ST. Well, why does PZ equal ST? Well, ST is PSZ plus ZT, and ZT plus SZ is equal to PS plus SC, which is equal to PC. You're probably saying, what? So I can now put ST right here. Okay, so let's recap that. Where did PZ come from? Well, PZ is equal to PS plus SC. And that is equal to ST because ZT equals SC. ZT equals SC is this here. So PS plus SC equals this. So it's a transitive property or substitution property of equality, either one. So we're going to say substitution. And you're saying, well, what are we substituting here? Well, look at ST is equal to SZ plus ZT. So that's ST. PZ is PS plus SZ, and PS plus SZ equals ZT plus SZ, or SC plus ZT. They're the same. These are the same. So therefore, ST equals PS plus SC, and PS plus SC is PC. So it's like a two-stepper there, but it's a substitution property of equality. So PZ equals ST. So because this is PZ and PS plus ST is right here, PZ goes there. ST is SC plus ZT, and SC plus ZT is here. So we substitute in those two. All right. This can get a little confusing sometimes, but that's where the substitution came from. Okay, this is the end. This brings us to the end of chapter 2.4. These are the exercises I would like you to try. So have a great day.